Hey class, Mr. H here, just looking at section 2.2. 2.2 is on a bunch of different types of graphical displays. I'll go through a bunch of them. I got some here in this handout, and we'll take a look. So the first one is a stem and leaf plot. Each number is separated into a stem, which is basically your leftmost digit, and then a leaf, the rightmost digit or more than one sometimes. It's similar to a histogram, but the advantage to these is that the graph contains all of the original data, as opposed to a histogram where you create classes and then you kind of lose your original numbers. So let me show you how to create one. Let's construct one using the exam data from the previous example, or the previous section, actually. Okay, so if you think about those exam scores, right? If I go back to that original data set here, right? Maybe I'll erase all that because it's kind of messy now. You can see that you've got scores that are ranging from in the 50s to in the 90s, but all of the first digits and all of these values start with either 5, 6, 7, 8, or 9, and then end in some other value. Okay, so what I'm going to do when I start constructing my stem and leaf plot, the leftmost digit, sorry, getting a little busy, 5, 6, 7, 8, or 9. Okay, and then you're going to draw a line. Okay, and then you're just going to list the last digit on all those exam scores. So for example, in the 50s, I'm just going to list them all. Okay, so let me pause and I'm going to complete it and then we can talk about it, and so you don't have to watch me and get bored. So I went and completed it, and notice what I did. So for example, with the 50s, I put in 0, 1, 3, 4, 5, 9. That's because the raw data values were 50, 51, 53, 54, 55, and 59. Okay, and it's the same for each one. The 60s, I had 62, 65, 66, and 67 from, back in that raw list of datas. Okay, notice also if numbers repeat, like in the 70s, right, I've got 3 3s written there. That's because when I look back at my original data set, 73 appeared 3 times, right? 75 appeared twice. 78 appeared 4 times, okay? Okay, so there's your stem and leaf plot. It's kind of cool because, again, all of your original data is not lost. You have all those data values and you still have the structure. Like if you kind of leaned your head to the right, you can see the structure, like the heights of the bars. I guess even if I like played around with this a little bit, I can like rotate it, right? So then it does look like that histogram, right? With the bars, just like before, okay? So that was some pretty cool effects, right? So you were thinking, okay, well, if you still have the structure, why not just always use stem and leaf plots? Well, histograms are better if you have large data sets, right? Like this is nice because there's only 41 numbers. But if you had like 1,000 numbers, there's no way you're going to be able to list them all. Okay, so histogram is better for large data sets. Stem and leaf, better for kind of medium and small ones. Otherwise, you can look through some of these other graphical displays. This is a scatter plot. Scatter plots we'll get more into in chapter 9, but kind of get comfortable with looking at these values. You're kind of looking for patterns in the data with a scatter plot. This one, it's comparing income to a mental health index. So each dot probably represents a person, and it gives you 2 values. And then you can see some data and some patterns in the data. Okay. Pretty typical one is a pie chart. We've seen those a lot. This one is what's called a Pareto chart also has an ogive on there. So there's two graphs. Usually those go together, Pareto and ogive. All right. Pareto is like a bar graph. The quality of a Pareto, so the Pareto are the bars here, is that the bars go in descending order. So the highest bar is always first, and then it goes down from there. And it's qualitative data, right? There's no numbers here, but only categories and words. So it's all just qualitative, no numbers, just words, okay? An ogive is this. That actually is the cumulative frequencies, right? So ogives just there's a dot for each cumulative frequency for each class. Okay. All right. Then you have a dot plot. Dot plot is just kind of a frequency. You know, how many brothers and sisters do you have, right? So each dot is a person in the survey, I guess. So 2 people in the survey had no siblings, right? 3 people in the survey had 3, right? 2 people in the survey had 4 siblings, right? 3 people in the survey had 1 sibling, and then 5 people in the survey had 2 siblings. Okay, and then a little time series as you go along. A timeline, what happens to the data, in this case, sales. All right, so if you want to take a moment and try to answer these questions based off of those graphs, you can do it. But let's look at them. If you want to hit pause and try it yourself first, that's always a good idea. So any general patterns you see in the relationship between income and Metro Health Index? So that's that scatter plot. Any patterns? Well, it looks like it's trending upwards, right? As income tends to rise, so does the health index, right? Just looking at that general pattern, it is rising, okay? So as one increases, the other tends to increase as well, right? So as one increases, the other increases as well. That's awful handwriting. I'll clean that up. What total percent of people would describe their favorite movie type as drama or romance? All right, that's the pie chart. Drama or romance? Looks like a total of 30 plus 5, 35%. Okay, so that would be the answer to that one. Pretty straightforward. 35%. Think about a pie chart. Make sure it adds up to 100%. Right, all those pie pieces should add up to a total of 100. What was the most common type of failure in manufacturing in 2016? Most common type of failure, if we could read that, dimensional deviation had the highest bar, right? Dimensional deviation. Okay. That's pretty straightforward too, just reading that bar chart. Approximate the average number of siblings a person has. Right? What would you say? What would the average be? Well, this is a pretty symmetric looking graph. Looks like most people are in the middle, right? So I would say the average is around 2 siblings. And then finally, describe the trend in company sales over time. A little erratic, right? But it is trending upwards with some dips involved, right? But general trend is up with some dips, right? All right, so it increases with occasional drops over time. Okay. One other thing I'll talk about in this video is when graphs go wrong or mislead you. So I'm going to bring up a different handout, which you also have access to. It's just called Misleading Graphs, right? So here's a graph, talks about average house prices and comparing 2 years. Whoa, look at this, 1999, the price of houses skyrocketed, right? as compared to 1998 based on this display. But if we look at this a little closer, is that really true? Okay, because if we look at that y-axis, this is 80,000 and this is 82,000. So really the price only went up by 2,000, right? But that doesn't seem right looking at the bars, right? This bar is just so much higher than this bar. The reason for that is, where are we starting here, right? That value right there is not zero, right? This is 79,000, 79K, right? So they didn't include a lot of the bar, right? Like these bars go down a lot farther. This graph is just showing us the tip of those bars, which is kind of misleading, right? Because if we showed the entire bar, it looks like this, right? If we start here at 0, now we have a better comparison of these 2 years. They almost look identical, okay? So when you see a graph, especially a bar graph, always look at that y-axis. It should start at 0. If it's starting at something else besides 0, it's going to be misleading. If you don't, if you do see this in the media, here's a screenshot of this exact thing happening, right? People on welfare compared to people with a full-time job, right? Oh, wow, people on welfare, look at that bar. It's way like 5 times as tall as this bar, but they are not starting at 0 here. This value, even, I mean, they don't even label it, right? But that looks like it's starting already at 100 million. Okay, so these two, if you continue those bars down to the true y-axis, I mean x-axis, right? These two bars would be very similar. Okay. Anyway, all right, I'm gonna stop there. Hope all's well. Shoot me questions if you have any.